You know, AI is hungry for power. I mean, insanely hungry. But what if that same power-hungry technology is also our secret weapon for building a cleaner, more stable energy grid? It's a huge paradox, right? Well, let's dive in and take a look at the playbook big tech is writing to solve it.
So that's really the big question we're tackling here. It sounds like a total contradiction, doesn't it? How can the thing causing the problem also be the solution? Well, the strategy is way more sophisticated than you might think. We're going to break down exactly how it works.
All right, first things first, let's get a handle on the sheer scale of this challenge. We're talking about a projection from the International Energy Agency that by 2030, data centers could be chewing through 945 terawatt-hours of electricity every single year. To put that into perspective for you, that's about what the entire country of Japan uses in a year. And yeah, AI is the #1 thing driving that explosive growth.
Now, when you see a number that big, it's pretty easy to just see a disaster in the making. But the very companies driving this demand, they're also engineering a pretty clever solution. And listen, it's not just one magic bullet. It's a strategic playbook with 3 really distinct, powerful plays.
Okay, play number 1. This one starts at home, right inside the data centers themselves. You know, before you go out and try to change the world, you gotta get your own house in order. So this is all about using AI to clean up its own massive mess.
And here is a perfect example of this in action. Google actually turned its own DeepMind AI loose on its own data centers. And the result? The AI learned how to manage all the cooling systems so efficiently that it slashed the energy used for cooling by up to 40%. That is a huge saving, and it's all done by using AI to fight AI's own waste.
And the efficiency gains go all the way down to the silicon. I mean, check out this claim from NVIDIA. A staggering 100,000-fold improvement in the energy efficiency of its chips for running these big AI models, and that's just over the last decade. So here's the key takeaway. While the overall demand is soaring, the energy needed for each individual calculation is absolutely plummeting. Bending that curve is critical.
So, let's move on to the second play in the book. This is where things get really smart. It's where software intelligence meets the day-to-day reality of the power grid. It's not just about how much power you use, but when and where you use it.
And this is the core idea. It's called carbon-aware computing. Think of it like this. Let's say the wind is blowing like crazy in Iowa, and the sun is just beating down in Arizona. Can you shift your non-urgent computing jobs to take advantage of all that cheap, clean power? The answer is absolutely yes, and it is a total game changer.
And this strategy has evolved super fast. I mean, Google started back in 2020 by just time shifting, basically running jobs when local renewables were at their peak. A year later, in 2021, they were location shifting, moving jobs between data centers all over the world. And now they're using it for demand response, which means they're actively powering down to help keep the entire grid stable during peak times. And that brings us to the third, and frankly, the most ambitious play of all. This is where the tech giants stop being just massive consumers of energy and start using their financial power to fundamentally remake the energy grid itself. We're talking about financing the next generation of clean power.
To really get this, you have to understand the difference between the old way and the new way. The old way, annual matching, is kind of like buying 365 apples in October and then claiming you ate an apple a day all year. The new way, 24/7 carbon-free energy, or CFE, is the real deal. It means making sure that every single hour of your operation is powered by real, local, clean energy. That's what actually cleans up the grid.
So how do you get that 24/7 clean power? Well, you have to build it. And this is a perfect example. Out in Nevada, Google didn't just buy some solar power, they helped finance a next-generation geothermal plant with a company called Fervo Energy. Geothermal is so powerful because unlike wind or solar, it can run around the clock, giving you that firm, clean power you need.
And look, it starts small, but it's designed to scale up and fast. The first project is online right now, feeding about 3.5 megawatts to the grid. But because it worked, there's a whole new plan in place to expand that to over 115 megawatts. This is the model. Prove it works, then scale it way up.
And here's the financial magic behind how they make it happen. It's a simple but brilliant loop. First, a company like Google or Microsoft guarantees they'll buy the power for decades. That guarantee makes it possible for developers to get the financing for brand new, innovative projects. Think geothermal or even small modular reactors. And finally, that new, reliable, clean power gets added to the grid, and that benefits everybody, not just the tech company.
So with this three-part playbook, you've got efficiency, carbon awareness, and grid building. How's the game actually going? Let's take a look at a balanced scoreboard, looking at the progress and the tough realities that are still out there.
Look, the wins are definitely real. We're seeing huge efficiency gains, new financial tools that are creating real, firm, clean power, and next-gen projects are actually coming online. But the challenges are just as real. The crazy growth of AI means that for some companies, total emissions are still going up. There are big debates about the right way to even account for emissions, and, the slow pace of government policy and permitting is still a massive hurdle. So the bottom line is, the playbook is impressive, but this game is far from over.
And so, this all leaves us with one massive, critical question. The biggest, most sophisticated companies on the planet have created a roadmap to turn their greatest liability into an engine for decarbonization. They've shown it can be done. But can these strategies scale beyond big tech? Can our governments, our utilities, and other industries learn this playbook fast enough to really change the outcome for the entire grid? Well, that is the challenge ahead of us.